This is definitely going to be one of my nerdier videos. Welcome to the first in a series where I explore different interesting topics while drawing something inspired by them. Feel free to put this on in the background while you work, study, or even fall asleep. There won't be any loud noises, just some relaxing chats about fungi. Today, I wanted to design a scientific-looking graphic around mushroom photos I took last year, and it got me thinking about the science behind these insane freaks of nature. I was going through old photos, and the question that kept popping up in my mind was, why do some of these look so weird? It led me down quite the rabbit hole of discoveries about fungi and what they actually are. Thousands of microscopic tubes called hyphae sit under your feet right now. If you've ever wondered why those mushrooms in your backyard keep popping up even if you've pulled them from the soil, it's because what you see above ground is just the fruiting body of the whole structure. In reality, the structure of the entire hyphae can be anywhere from a meter to a kilometer long if stretched out straight. All of that is usually packed into a square meter, sometimes more if the hyphae follow tree roots much deeper into the soil. The genus of fungi I'm drawing today are Clavariodelphis, with a specific species listed as Clavariodelphis occidentalis. Keep in mind that many Clavariodelphis species look incredibly similar, so I'm not sure if the mushrooms I photographed are specifically occidentalis or another lookalike mushroom in the Clavariodelphis genus. Any following information is on occidentalis. Usually when you think of fungi, you think of the brown-capped mushrooms or guild mushrooms that you can find on your dinner plate or in your backyard. But these are taller, longer in shape, and a dull yellow or pink color. They usually grow 10 to 20 centimeters in small clusters at the base of trees. They're a mycorrhizal species, which means they only grow alongside specific trees. These ones in particular commonly grow alongside coniferous trees like firs and pines, and the one I photographed was found in a black spruce bog. They won't kill you if you eat them, but they're not particularly tasty either. Mycologist David Aurora, as cited in literally every paper I've read on these, says they taste like stale rope. According to the Mushroom Appreciation Club, they are great for amino acids and high-quality proteins. So maybe in the Last of Us type situation I would eat these, but they wouldn't exactly be my first pick for my muscle gain dinners. So why do these mushrooms look like that, instead of having the cap and gills that most of your everyday mushrooms have? Well, it's simple really. Reproduction. Those gills, the soft undersides of mushrooms like portobellos, are what produce the mushroom's spores. Because they fold, they have a larger surface area, where microscopic cells called basidia produce the spores and shoot them out so they can catch air, currents, and travel. The cap of a mushroom helps protect the precious reproductive area from rain, wind, and other environmental dangers. This is what we grow up knowing the most about, because it's what we see in media. But a majority of fungi don't look like that at all. Remember the hyphae from before? That's the most common structure that fungi form, though not a taxonomical group itself. Hyphae structures can connect together into a large thread system called mycelium. Minecraft lovers, you know what's up. Molds are not only structured like hyphae, but many are actually made of teeny tiny hyphae structures. Yeast is also a fungi, just a single-celled version. You may also be familiar with shelf-shaped mushrooms like you would find on trees, often called conchs. Yes, me and my friends also laughed at the name back in 7th grade. Instead of gills, these conchs have smooth exteriors covered in pores, a lot like our skin. This kind of mushroom is called a polypore. These pores release billions of spores and let gravity and wind do the rest. Among all these fascinating structures, you have our Clavariodelphis genus. They don't have gills, clearly, but they also don't have pores. Instead, the spores grow directly on the outside surface. This makes it easier for wind to pick up spores, especially the taller they get. Many other groups of fungi evolved to repopulate this way too, like the much creepier named dead man's fingers. I would have explored deeper into the taxonomy and history of these fungi, but honestly there isn't much concrete information. Before 1989, occidentalis was completely misidentified as its identical sister fungus, Clavariodelphis pistillaris. We know C. occidentalis shared a common ancestor with Clavariodelphis pistillaris, a nearly identical looking fungus that grows in hardwood European forests. Scientists only know that this common ancestor most likely existed and spanned across Laurasia, an ancient supercontinent that would eventually split into North America and Eurasia. This is when they estimate the continental split between pistillaris and occidentalis happened, so about 55 to 60 million years ago in the late Paleocene epoch. It's theorized that the way they reproduce has stayed relatively the same because its simplicity makes it reliable for a lot of different environmental conditions. So this little robust, weird-looking fungus is the result of millions of years of fungal evolution. If you're ever out for a hike among the coniferous forests of Western North America or Central America, look out for these little guys. They may not taste great, but they're an important part of the wider ecosystem of these forests. As always, thank you so much for watching. If you want to support more videos like these, I have an ACG goods store where I sell all these sciencey and artsy things that I do on this channel. I have posters, stickers, keychains, and more, and I'm currently looking into how to manufacture decks of cards so I can make mushroom identification cards that look like Pokemon cards. So if any of that interests you, the ACG goods store will be in the link below, and if you like the content, consider subscribing or dropping a like, it'll really help out. Alright, thanks again, cheers!